this test machine now is designed to carry out electroluminescence and flash testing on modules up to 2.6 meters and up to 800 watts. These are all calibrated, and the software enables us to get very accurate standard test conditions readings on point in time power. There is an international standard for quality testing, and we use this, which is ISO 2859-1.
Hello everyone, thank you for joining this new webinar. On today's webinar, we invited John Davies from 2 Degrees Kelvin to talk about the upstream and downstream module testing. Upstream is the part of testing in the factories before shipment, and downstream are the various tests that can be performed after the shipment when the modules arrive on site. Today we start the webinar. First, we have about 30 to 40 minutes the webinar, and after that, around 15 minutes Q&A. Some practical things: you can ask your questions in the chat box on the right of your screen, and we will answer your questions at the end of the webinar. Then you will also automatically receive the recording of the webinar once the webinar is finished. Right now, let me introduce you to our guest speaker, John Davies. So, John Davies is the founder and CEO of 2 Degrees Kelvin and is based in the UK. As a chartered engineer, he's been in the energy industry since 2003 and working on large-scale solar projects since 2012. Right now, John is specialized in solar farm quality management and all the testing that's involved with that. John is also the author of the best-selling book, The Solar Boom, which you can find on Amazon. Then, Degrees Kelvin, the founder and managing director of Sinovoltaics. Degrees started 14 years ago in the solar industry, where he set up and managed a PV module factory in China. Then, since 10 years ago, he started Sinovoltaics and has overseen the technical de-risking of over 15 gigawatts of PV projects. Then myself, Benoit van der Maas. I've been working at Sinovoltaics since 2019, and I've been helping our clients to implement quality strategies for their procurement. Now, I'd like to give the word to John Davies from 2 Degrees Kelvin.
Hello, everyone. Thank you for joining us today on this interesting webinar. And thanks to Sinovoltaics for the invitation and collaboration on this webinar. Really poignant and important set of services and solutions that both our organizations deliver. So hopefully I've just shared some insights and advantages in terms of the downstream part, which 2 Degrees Kelvin are heavily involved with, and hand back to Sinovoltaics for likewise the same sort of insights and advantages for the upstream side. A quick introduction, it's already been made actually, so I'll whiz past this, but I'm a chartered engineer. I've been in the energy industry for the last 20 years, and the last 10 years being in large-scale solar. And we've already mentioned my book, so we won't mention that again. For those of you who've read it, really appreciate you purchasing it. And yeah, I started 2 Degrees Kelvin back in 2019. I'm the founder and CEO, and we're a solar engineering business essentially, and we have developed a range of project lifecycle services and solutions to meet the needs and the gaps within the emerging utility scale solar industry. I was working in the large scale solar industry during the subsidy driven solar boom between 2010 to 2016 in the UK. So we've really been there and got the t-shirt and seen how solar should be built and how it shouldn't be. We've provided a range of services on up to 2 gigawatts of assets now in the UK, which we're incredibly proud of. And our testing services are really where we've come from, and that's what we're most and best known for. We've tested over 50,000 modules in the field with various different test applications. We have 4 main divisions within 2 Degrees Kelvin. The first one servicing the design and development phase of solar farms is our engineering consultancy and technical advisory division. We then offer a range of EPC construction and commissioning support services to EPCs and IPPs with large-scale solar projects. We have a range of advanced inspection services as well, including some of the things that we're going to be talking to you today. And we're also heavily involved in the aging fleet of assets and looking to extend asset life and optimize operational assets. So on to the main topic of today's discussion, insights and advantages of upstream and downstream PV module testing. So to start with, it's been touched on by Benoit, but just in terms of terminology, upstream and downstream, it's quite simple really. Everything that's at the manufacturing point of facility is upstream, and everything that's on site as soon as those modules arrive on site, that's downstream. So there's a clear distinction really in terms of our 2 organizations and the services we provide. We're very much focused on on-site services and ensuring that modules are in the best condition possible going into a brand new asset. And rather than listing specific services, I thought I'd just highlight here some of the risks that procurers, EPCs, IPPs, project owners will face at the various stages. So just to rattle through some of these upstream risks that Sinovoltaics deal with for their clients, you've got, of course, the manufacturer selection in the first instance and all of the various parameters and drivers around that. We've got the bill of material sources, all of the different components that make up the solar panels themselves and the quality of those components, manufacturing processes within the manufacturing facilities themselves, trying to eliminate or minimize embedded defects across batches of solar modules. You're also dealing with the rapid advancements in technology and module and cell design, which is quite hard to keep hold of at the moment. Really crazy pace of advancements. You have the factory testing validity. So are they testing in line with various regulations and standards? Price fluctuation, of course, of raw materials and modules and distribution all over the world. And demand and availability, of course, it's a seller's market at the moment. Solar is rapidly being deployed on a global basis at rates we've never seen before. So keeping up with all of those. Then you have the logistics and program impacts. So when can you get certain volumes of modules over to the UK or wherever you're building your solar farms within the world? And of course, you've got your procurement contracts and legal disputes and on all of that side. So that's very much Sinovoltaics bag. And then what we're dealing with on a daily basis now, we're fully deployed and booked up at least 2 months in advance for large-scale solar farm post-shipment testing and post-installation testing. We're dealing with delivery schedule delays. We quite often see now in a post-Brexit UK stacks and containers of modules in various ports trying to get into the UK. So that's something we're dealing with. Offloading risks. We're trying to optimize how many modules and pallets we're getting into containers and curtain side lorries at the moment. So the more they're jam-packed, the more difficult it is to offload and making sure that we distribute them sensibly on site and in time for installation. We don't want these modules and pallets hanging around in the field for too long, where there's risk of further damage or deterioration of packaging, etc. Then, of course, you've got the installation risk. All of these modules come with installation manuals, but we've seen clear evidence from the subsidy-driven solar boom when it was very much get it in as soon as possible. We were under a time pressure to get them in, that modules were quite literally thrown into position on some sites, and there's widespread mechanical damage. So we're focusing in on installation standards and accountability of various installation teams on sites, and making sure that they're doing it correctly. You've got the clamping and torquing, or over torquing of clamps, thing to keep on top of, and making sure that that's done correctly. You have widespread invisible damage, which obviously you can't see without these advanced inspection methodologies. And of course, manufacturing defects that we're seeing with the volume of manufacturing going on at the moment. We're seeing, quite a bit of manufacturing defects coming through with tier 1 modules. And then I suppose what we're wrestling with at the moment is we've got employers' requirements document, which is the technical specification to build the sites. In some cases are not interested in proactive module testing, and they're reliant on string testing and IV curve testing, which really is a very indicative sort of source of testing and finding out information and knowledge about the health of your modules before they go in. It's good to understand whether a string is connected or not, and you may see some variation on some amperages there, but nothing that you're going to do anything with. You're not going to know where the defect is, what it is, where it came from, and who's accountable for that defect. So quite a lot to think about. Just to bring you through some of our on-site module testing services that we have developed. We have a range of post-shipment and post-installation testing services and technologies. We've recently purchased our long wheelbase vehicle mounted testing simulator, which is a mobile laboratory. This is calibrated on an annual basis and has manufacturing line accuracies plus or minus 3%. And this particular test machine, they've all got sort of female names. So this one's Elizabeth, or Lizzie for short. And this test machine now is designed to carry out electroluminescence and flash testing on modules up to 2.6 meters and up to 800 watts. So we future-proofed ourselves for a certain period, although who knows where we're going to go in terms of module power classes in the future. We're doing a lot of testing on this at the moment because, of course, all of the modules coming into the UK for large-scale new build are these sort of 500 watt and up modules. Sandra is our older MBJ test lab, and that has a 2 meter height limitation, so it can test up to sort of 350 watt size modules, and that's very much focused on servicing the operational fleet in the UK. It's actually easier to use, and it's quicker, but of course there's a lot more technology and a lot more cameras on the more modern and newer MBJ5 Max, so it's slightly more onerous on the data and things like that. But those two are our versatile mobile test machines. We then have an offering a dark room method for electroluminescence testing only. So we'll carry out a visual inspection of modules and we'll be able to carry out an electroluminescence. Now, this is for educated clients or who actually value electroluminescence more than the flash. They may well have had flash testing already within the procurement or manufacturing contracts. So they just want the EL. So we use a range of containers or cabin units on site to create this dark room. We have a standardized carbon fiber goalpost frame with our electroluminescence camera and power supply system, and this works very well. You actually get a lot more through on a daily basis, which suits certain clients. And then, of course, we've got our range of in situ or post installation tripod systems, and this is done at night. There are daytime solutions out there that we're experimenting with at the moment, but tried and tested is nighttime EL with our tripods, and we've tested close to probably 8,000 or 9,000 modules in situ for new build sites over the last couple of years, So we've got all of our health and safety covered, and we work very, very safely and efficiently at night. We also have partners, APVI, who are leaders in the world in terms of high volume electroluminescence. And we work very closely with these guys if there's high volume. So if there's multiple thousands or megawatts worth, then this company will come into the UK with us, and they will have multi EL camera headed tripod systems, which is quite cool, quite sophisticated switching systems, so it all can be done very efficiently. So what are we actually measuring? So this is the crux of it, really. We do offer a visual inspection service as part of what we're doing. We see and handle every single module that we test. So we do look for the quality of the sealing, the silicone work, the junction box integrity. We often find issues with those that sometimes are replaceable or repairable on site, and others we just have to put the module to one side. DC connectors and cable damage is another one. We've always got an eye on those. And of course, pallet and frame damage. So if we see damage on a pallet, we've got a duty of care really to raise that as a concern and possibly test more of that pallet. Our main mobile test labs, they carry out connection continuity checks, and they also carry out a diode function test as well. So although quite rare in modern modules, for brand new modules, we are seeing them, but it's sort of below 1% really in terms of seeing diode failures on brand new modules. You tend to see them in the field actually once they've been installed, whether that's a mechanical disruption that's causing the substrings connections to break or something like that. And of course then electroluminescence tests. So we're putting a current through the module, and we're getting it to emit light much like an LED, and our specialist cameras then pick up this image like an X-ray image in the electroluminescence light range. And then of course we've got a flash test facility. So these are all calibrated, and the software enables us to get very accurate standard test conditions readings on point in time power class, so we can verify whether it's a brand new module or it's been in the field for a certain amount of time. We can verify where it is currently and where it should be against its warranties and guarantees. The next thing that we get pulled in on quite a lot in the UK as this proactive approach is maturing is actually how many modules to test. Now there is an international standard for quality testing, and we use this, which is ISO 2859-1, and the AQL tables within. We usually apply these to create either minimum compliance, which we're seeing a lot because of course all of this costs money and impact on the program, but also some of our clients are following best industry practice and going slightly higher. So what we do is for new build solar projects, we're defining a container or lorry load as the lot size. And now this is because this individual load has been exposed to individual forces on route and on the road. So we see that's the best way. Typically, we're seeing volumes of modules within a single container around somewhere between 620 to 720 modules, which then you can follow the tables themselves to find out where that volume sits in that first table on the right hand side there. So the identification of that red box there is the line, and then we need to apply the general inspection level or special inspection level that the ERs or the client calls for. And now we can recommend minimum compliance in this area. Spits out a sample size code of C, which would be 5 modules per container, or 5 modules from one pallet, and 1 pallet per container. But we are seeing industry best practice, more proactive and risk averse clients who are pushing for 13 modules per container, which is E. So they would be following, in this case, they'd be following special level inspection 3. We have to apply a standardized judgment criteria, the way that we go into these electroluminescence images, and we assess the power based on power class. We apply these judgment criterias, and we were able to classify the modules. And typically in this particular judgment criteria, you have class A's and B's are acceptable, class C's and D's are not, and those modules would be rejected. And then we apply a certain escalation protocol then, so there's a rejection level. And these sorts of things need to be discussed openly with your module supplier upfront, so that if we do find issues on site that are major defects and are rejectable, and we follow the escalation protocols, that they are aligned with those expectations. In some cases, entire containers or batches have been rejected, and to avoid those lengthy disputes, you need to be aligned on expectations in terms of major defects and escalations. A lot of our day-to-day operational challenges are around actually preparing for module testing on site. So we're working with a lot of people who haven't done these sorts of tests before. Typically, we've called for on-site assistance in the past, whereas now we actually recommend a full wrapped service from us. So we have our own telehandler driver, we have our own test facilities on site, and we maneuver, unpack, test, and repack all of the modules ourselves. And in this way, we can optimize our workflows, and we can actually generate more value for our clients, rather than being provided with an array of different levels and intensities of labor that we need to train each time and get up to speed. So these are a few photos here of some of the site setups, but typically it consists of a marquee. Being from the UK, anyone who knows the UK knows it rains a lot here, so we need to be prepared for downpours and to be able to work through inclement weather. And this is just a couple of the setups here. And just some points really for everyone's understanding. We usually set up a defined test zone, approximately 20 meters by 20 meters. We need it to be on rolled, clean stone, so that we're not testing in the mud. Usually Heres fenced off with suitable signage and things like that. The representative samples, so the individual pallets that are extracted out of each container as they're being offloaded, should be segregated and be close to the test position, and they should be marked with a reference, whether that's a number or a serial number for that particular container, so we have a reference of where they've come from. We have an industrial marquee, which we usually reverse our test machine or place our container into, so that we can work within there in bad weather. We have a power supply there that can power our test equipment. And then we typically provide a dedicated module handling team and telehandler on site, so that we are self-managing and we can get on with testing modules, which is what we're being paid to do. Also, another important point is that these packs, these pallets of modules have been packed very carefully and in a very high volume automated way in Asia. And when they get to us, the banding is under pressure. So you need to support the modules very well and very carefully. And you need to be prepared then with high tensile grade banding equipment on site, so that you can secure these modules once they've been tested and we've unlocked or broken the seal, if you like, on these pallets, and they're loose, that we can put them back and we can tighten them up and make sure that they're suitable for ongoing module distribution within the site. And all of that really relates to electroluminescence and flash tests in the post delivery side of things. But on the post installation side, what we're just in terms of workflow and throughput, we call for modules to be tested on the bottom rows of each row, and that's really just to minimize, stretching and reaching and working at height at night. And we also call for all of the DC connectors to be loose and ready to go. What we don't want to be doing is taking off cable ties and unconnecting DC connectors and then reversing that in the middle of the night. We're there to test and to get volume, and then those sorts of things can be sorted then in the day. So just wanted to share some of the types of faults that we're seeing, and this is typically broken down into mechanical and then manufacturing related defects. These are only a small number of them. There's quite a variety, but just to give everyone listening an idea of the extent and the type of defects that we're looking at. This is probably the worst case, and when you start doing electroluminescence testing, particularly in the field, you do see some extreme cases and some severe damage. And whether this is an engineering geek type thing, but it's almost the more damage the better for us as geeky engineers. So this one here is a typical example of installation damage. This is quite clearly been mishandled and put in and installed in a bad way and not very careful way. You cannot see this damage. Looking at the module, it looks completely smooth. The glass is still intact. This is just purely electroluminescence and the state of the silicon wafers themselves. So that's extreme cell fractures. You have the next one there, which is very fine. Actually, it's not a great example of an X crack. We see X cracks and V cracks, particularly with more modern split cell and high volume busbar design modules. We're seeing X cracks and V cracks, which are mechanically sort of induced around these busbar stress raisers. So we see a fair few of those. We're seeing quite a lot of shattered glass, particularly glass technology at the moment. Some of this, I hazard a guess at probably half of the damage that we're seeing is due to offloading methodology. So if you just go straight in with a fork truck, the fork truck will be applying a mechanical load on the junction boxes due to their location on the outside of the pallet. And we're seeing sort of repetitive smashed glass where telehandlers have taken it out of the containers or the lorries. So it's a very simple fix. You can put some wooden blocks across so that the frame is taking that load, and you avoid any point impact. But we see this quite a lot, and obviously we don't test smash panels, so we would just be putting those to one side. But there's a lot of emphasis on new builds to reduce the damage rates, because essentially you're just throwing money away. And another example, which we're seeing quite a lot of, is poor silicone work and junction box fixing. So quite often the plastic caps are missing off the junction boxes. You have examples like this where silicon's heavily applied. It's affecting actually the power output of the module in this case significantly. On to some manufacturing defects now. So alarmingly, in the last 2 years, since really the subsidy-free second wave is kicking off in the UK, we're seeing a lot more manufacturing defects compared with mechanical damage. Mechanical damage is still there, but manufacturing defects, and what we mean by this is these aren't caused by anything, any sort of external forces or anything on site. These are based on either the cell or the module manufacturing themselves. So we're seeing a lot of grid finger interruptions. We're seeing striation rings now, which is a new phenomenon related to over-oxidization of the ingot during the manufacture of that particular component. We've seen soldering issues and connection issues and chain patterning and lots of different things, weird watermarks, and all relating really to either the bill of materials or the assembly and formation of the modules themselves. And what we're doing really is we're just doing sort of volumetric statistical analysis on these. How many affected cells are there on a given module, on a given batch, on a given power class, and we're presenting these as sort of with factual insights. I just wanted to share a quick striation rings related case study here. Now, I've obviously denamed this and changed some of the figures just to make sure that it's you know, that we're not going against sort of NDAs and things like that. But this is a real example that's happened in the last 12 months. It's a UK-based solar farm, 35 megawatts. We were commissioned to do electroluminescence and electroluminescence and flash testing using our MBJ 5.0 Max, which is Lizzie. We tested around 1,200 modules, and this is from a tier 1 top 10 international module supplier, and split over 2 power classes. So we had 560s and 565s, and what we saw was an extensive, you know, quantity of these striation rings, and we didn't really know much about it at the time, but we did some research and we understood why this was happening. We understood that from a manufacturing perspective, they have their own EL criteria, and they didn't sort of relate this to power loss or anything like that. It was merely just a visual defect. So anyway, we got on with the testing and we started to collect the volumes of striation rings affected cells per module to go through. And what we found was that there was 95% of the modules that we tested on the lower power class contained striation rings, and the average number of cells per module was 14. So that's significant. But quite interestingly, then the higher power class was only 56% of modules contained rings, and an average of 2 cells per module. So a lot less. And leading on to that, then looking at the power and how it related, 65% of the lower power class were under nameplate, and only 4% of the higher power class were under nameplate. So although that doesn't categorically prove that the striation rings are related to power loss, it's quite clear from that data that there's a convergence there. And what we had to inspect the OEM's EL criteria to understand, right, what's the rejection rate? Because some modules, 144 split cells on a module, some modules had 60 or 70 cells affected, so it was quite significant. And what we found was that actually it was a very high threshold that they'd set. So on the bottom of this slide here, you have this gray scale, and what needs to happen for a major defect or a module to be rejected relating to striation rings is actually you need a 30% grayscale difference in darkness of the ring compared with the rest of the cell, which is quite difficult to do and quite difficult to find. Now, we found quite a few of these with over 30%, but what you actually need is 14 cells over 30% on a single module to be rejected. So the threshold for rejection in this particular case for striation rings was very, very high. So none of these modules would have failed under their own EL criteria. Just wanted to share that with you because it's quite an interesting one. Now, just some rough figures that we've looked at here to actually calculate what the impact is. So on average, the sort of lower power class, just looking at that alone, on about 45% of the site was this power class. We were looking at about just over 4 watts, which is 0.7% on average power loss or below power class. Now, if you apply that then to the annual production of the site, you're looking at around £42,000 per year, or over 40 years of the site, 1.7 million. So this is just just a very small element of one particular defect and the sort of impact it can have on life cycle production losses. It also, of course, then had an impact. So there was some delays in terms of the negotiation around the defect and how that was going to be solved. Actually, in this case, the OEM stepped up and replaced that entire batch. which I thought was fantastic actually, and very professional of them. There was an impact on project schedule. Obviously, all the modules needed to be quarantined, the defective ones, and the new ones need to come in. So there was additional costs involved in that. There was more testing that needed to be done to make sure that those same range of defects weren't carried through to the next lot of batches. And of course, there was additional upstream bill of materials checks then to make sure that they weren't being shipped before they had confidence that the striation ring issue wasn't there. So that was just some insights to one particular case study. There are quite a variety out there of things going on at the moment, and statistically, we're looking for defects. We're looking to protect project owners' interest and assets, and make sure that we don't put defects into a brand new system. That's what we're looking to do. So there's a plethora of different advantages here. Obviously, avoid installing damaged and defective modules, as I've just said. Ensure that your chosen manufacturer is ticking all the boxes in terms of what you're looking to do. There's a very high suitable product quality and price balance there. You're checking that new designs and configurations are suitable and no inherent defects are coming through with particular types of modules. You can also sort of verify that upstream testing, that they haven't missed anything. We're quite often, not with Sinovoltaics, but sometimes modules have been tested in manufacturing facilities and we've still picked up issues downstream. And of course, we're trying to identify issues that may evolve and worsen over time into performance loss issues. So it might not be affecting the power production now, and it might not be below nameplate now, but if they deteriorate over time, they may lead to more mechanical or integral defects. And of course, what we're doing here is we're applying best industry quality management practices. We're trying to make solar better. We're trying to build high quality assets which are going to last 35 to 40 years. And that's another thing as well. So we've jumped over the last few years from 25 to 30-year assets to 35 to 40-year assets. Now, module advancements have moved during that time, but not necessarily in line with those. That's very much a sort of financial model-driven strategy there. But we need to put in quality if we're going to get these assets to last. And I'd leave you with this thought, really, was the question shouldn't be whether you can afford to invest in proactive quality testing, and that's upstream and downstream. You know, the question should be, can you afford not to? There we are. So I'll hand back now to Sinovoltaics for their part of the webinar.
John, thanks for this presentation. Interesting to see the issues you presented in the field. Issues in the field or warranty claims, they're usually kept a bit silent in the industry. So it's interesting to see what's really going on. Okay, I have a short presentation. I will try to keep it within 10-15 minutes. You spoke about downstream testing. Sinovoltaics is mostly known for upstream testing. With other words, inspections at the factories in Asia. In this short presentation, I'd like to show you something new, something we just launched, so that you, to this webinar, you can say, that's something I haven't seen yet before. Before I do that, let me give you a short introduction on what we do, a bit of our philosophy around testing. Like I said, we're mostly known for performing inspections at the factories in Asia. So we have our own quality inspectors at the factories in China, Vietnam, Thailand, Malaysia, South Korea, India, Turkey. These are our own people, our own inspectors. So on one side, we focus on quality. So those are inspections, audits. And nowadays, also important part of our work is around traceability and ESG. We have about 17 gigawatt track record, and our objective is to contribute to 100 gigawatt of high performing solar projects in the coming years, which will probably keep us busy for another 10 years or so, and then we'll set a new objective. So I will show you in this presentation. I will show you some data, some inspection data, like a snapshot of what we've been inspecting in the past month. And I'm going to show you something new, which is related to our new quality guarantee. So I will tell you a bit more later on in the presentation. So the components we inspect is not just modules. We also inspect inverters, trackers, mounts, cables, transformers, and anything related to battery energy storage. So pretty much any component used in utility scale PV and energy storage projects. Nowadays, we're also ISO 17020 accredited. That means considered like our results are considered independent or impartial, and we're accredited to actually have the skills and the knowledge to do these kind of inspections, which is not unimportant for an inspection company like us. Just to show you, I will focus on solar modules because that's the topic of today. If you're buying from factories in Asia, these kind of services, they're very familiar to you. So I won't spend too long on it. Just to give you a short introduction on these services. So production monitoring means that during production, our team is on site at the factory from the beginning till the end. And processes are monitored, equipment is calibrated, and all the regular tests are being performed. Then there's a pre-shipment inspection. So let's say you're buying 100 megawatt from a factory. Typically, that order is divided in different batches. Let's say you have 10 different batches of 10 megawatt each. So a pre-shipment inspection is there to determine for each batch if it's a pass or a fail. And there's different tests that are being done, which is not so different from what John presented. There's IV testing, there's EL testing, there's a visual inspection. Then there's the bill of material check, which is a quite important check to verify that the manufacturer is actually sticking to the certified BOM. They're not allowed to use materials that have never been tested in that material combination before. Otherwise, you're practically buying an uncertified product. So we're strict on that. We inspect that. It's about 1 out of 6 inspections we see deviations in that. So it's something to keep a close look on. And then there's the packing and container loading supervision. I won't describe the whole procedure, but basically when you perform an inspection, there's typically rejections. And you, of course, want to make sure that when all the modules are loaded in the containers, that you keep out those modules that have been rejected on site. So that needs to be closely supervised. Then there's the 100% EL review. I would like to zoom in a little bit on this because it's a unique service and it's also closely related to our quality guarantee. John already spoke about EL imaging and how important it is to avoid certain micro cracks in your PV projects. Now, EL imaging is done at the factory on every single solar module, at least twice during production, one time before lamination and at one time at least as a finished product. And factories do review those images, but it's done manually. And defects can quite be easily overlooked. And this is how defects end up in your projects. So we have developed a method to do 100% EL reviews at the factory. We use our own software for this. It's called Selma. It's a Sinovoltaics EL-MES analysis. We're now at version 1.7. We've been using it for the past 3 years. And nowadays, all our clients, they benefit from 100% EL reviews. So the way it works is that this software is being used to analyze the EL images on the fly during production. And anything that is out of standard, any defects, those images are marked and they're filtered out. And those modules are replaced at the factory before shipment. So that's a unique service. We do this for all our clients. As far as I know, we're the only inspection company that does it for all orders. I can show you how that looks. I mean, John already showed some really nice examples of defects. So here you have some more of those. And the software nowadays marks them and also automatically recognize what type of defect there is. It can detect up to 15 different defects. Also, for instance, those striation rings that you mentioned, John. And I pulled some data from inspections. I thought this interesting to see what we really see when we do 100% EL reviews. So this is about a gigawatt of inspections that we've done in Q2 this year, over 2 million pieces. It's all done at tier ones, 2 factories in China, 1 in Vietnam. And I took out 2 indicators that I think are quite interesting. So our average replacement rate at the factory is 0.63%. Okay, that's not very high. I mean, it's more than 1,000 pieces per 100 megawatt. Still a significant number. But if you look at the rework rate, this is a really interesting indicator because it can differ from one factory to the other, and it tells you quite a bit. So our average rework rate, which is a repair rate, is 19.3%. And that means that 1 out of 5 modules, when we verify all the EL images at the factory, are out of standard during production and need to be somehow repaired. Now, the only way you can do that is before lamination. So that's why a factory does lamination, EL imaging before lamination. And such a repair means they would can, for instance, change the alignment of the strings, or they can prove some soldering, or even replace an entire cell if that cell is cracked. So you can see there's a lot of work going on at the factory to correct these mistakes, but as a result, the replacement rate is fairly low, and that's important because we want to make sure that everything that finally comes off the production line can be passed, because if you start rejecting shipments, there's also delay. So it's important to solve the actual issues during the production, and that's what we aim to do. So that's a snapshot of some data, and in relation to this, so after we do these 100% inspections, we are very confident about the quality of the modules, and not only us, so is our partner Munich Re, and that's the unique thing I wanted to show you. So we've just launched what we call the quality guarantee. The picture that you see was taken 2 weeks ago at the Munich Re headquarters during the first day of Intersolar. So it's a cooperation between Sinovoltaics and Munich Re, and what the quality guarantee is. Actually, I should first tell you why we launched this product. The reason why we launched this is we've been doing this since 2009, and throughout the years, quite some clients have asked us, you guys, you're doing all the inspections for us, but what if we really have issues in the field? Are you also liable? Do you compensate us for all the damage that we have, for all our trouble? And the reality is inspection companies typically do not take liquidated damages in projects. They don't really take liability. Of course, they're liable if they commit fraud or things like this, but typically the real risk is with the EPC, with the factory that provides a warranty, and eventually, of course, with the project owners. But the inspection companies typically do not carry any liability. So we've changed that. So the quality guarantee is a liquidated damages cover, and when we perform an inspection, and we do 100% inspection the way I've described it, if a client has an issue in the field in the first 3 years, and this leads to a warranty claim, they can immediately claim liquidated damages with us, with Sinovoltaics. And these funds can be used for all the costs you make that a factory doesn't cover. So when you have a warranty claim, a factory will replace the modules, but they will typically not cover, for instance, the de-assembly of the modules, or the reinstallation, or the logistics, or third-party inspection testing, like the services from John. So all these costs you make, they can, to a certain degree, be claimed with us. And when I say with us, I'm saying Sinovoltaics. Now, Sinovoltaics, you know who we are, but we're not Microsoft. So to give that more of a solid guarantee, Munich Re, they backstop this guarantee, and they're a known player in the insurance field. They're the largest insurer in the world, and that gives it a really solid foundation. I don't want to go in too much details now because we're limited on time. If you're a developer of large PV projects, you want to learn more about this quality guarantee, there's a link above the picture, sinovoltaics.com/quality-guarantee. That will lead you to a page, and there's also a form on there. Feel free to leave your details. We'll send you over a brochure with more information about this topic. And it's now an option since the 1st of July this year. So it's brand new. Okay, that was my part, actually. I don't think there's some more slides. So this shows you the factories were active. So we've been active at over 200 factories throughout the years. And here's just our contact details. You see here, by the way, our Switzerland office and our Spain office. They're listed here. Later this month, we're also opening our office in the USA. Will be announced shortly. Keep an eye on your email. If you're on our mailing list, you will learn more about it. That's another new news. But seeing the time zone we're active today, maybe there's not many listeners from the US. Anyway, that's my presentation for today, and I've seen some interesting questions coming by. So let's move on to the Q&A. Thanks.
So we have a couple questions here. Let's start with the first one for John. It's actually two questions in one. When you do on-site testing and you see many defects, what do you do next? And how many modules can be tested per day?
So it depends on the issue itself, really. If it's significant, if it's severe, then we'll certainly raise it with our client immediately on site. If it's minor and it's not likely to affect the classification and therefore rejection of the module, then we would just make a note and make sure that we've identified where that defect is in which batch, in which pallet. So it really depends on what we find. In terms of testing, our new test machine, we're aiming between 100 to 150 modules per day. It's not quite as fast as our older test machine, but just because of the quantity and quality of EL imagery, essentially, and the size of the the individual module files. So that's our target. We're more like 200, 225 with our older machine, and a similar sort of daily rate for EL only. On the nighttime EL, it's somewhere between 150 and 250, depending on the amount of movements on site. If it's all in one area, obviously we can do more rather than moving around to different parts of the site.
Okay, great. Thank you, John. Then we have next question from Eric. So Eric is asking, after testing, how the modules will be packed, horizontal or still vertical?
Absolutely. So what we're trying to do is a balance really of making sure we have a representative sample, but equally not taking apart 5 different pallets to get individual modules out of the middle of those pallets. For example, that's an extreme case. You have to unpack and repack each pallet that we disturb. So we try to minimize that, and we unpack it, make sure it's suitably supported, and we actually test 5 modules, straight from that pack in a vertical position, and we replace them as they've been removed. So they're vertically packed. We don't take the whole pack aside. Now that's on the 5. If it were 5 per pallet. If it's 13, sometimes we have cases where our client or a TA involved perhaps wants to see modules from the outside of each pallet and then every other module. In those cases, it's slightly different. But in all cases, we repack vertically, and then we replace the quantity of banding as it was originally packed. Thanks, Eric.
Okay, great. Then Eric had one more question. So do you see a lot of back glass breakage with new modules, more than front glass?
Yes. I'm not sure about percentages, but the majority of breakages we're seeing on the rear, which happens to be where the junction boxes are, and that's we didn't have to do much forensic investigation. We could see what was causing a lot of these breakages we were seeing, and that might be on the way in or it might be on the way out. But certainly on every site that we go to, we just share that insight really with the EPC or the main contractor who's offloading to make sure that they can reduce their breakage rates. But the rear, we're seeing it more so, yes.
Okay, great. Then we have another question for Degrees. So the material listed on CDF doesn't mean that all the combinations are really tested together. How critical is this topic? And is it necessary that the BOM is really tested before in that exact combination as a module?
Yeah, that's a good question. So maybe the starting point of the bill of material list, like the official list, is the CDF, which is issued by the certification body, often of a player like TÜV Rheinland. Now, when a new solar module is certified, the factory will submit samples to the CB, let's say TÜV Rheinland, and they need to very specifically mention which raw materials have been used to create those samples, and those raw materials. So when the samples pass all the certification tests and they get issued the product certifications, these certifications come with the CDF. So all these raw materials are listed on the CDF, and what you see is that a factory has multiple options per raw material. So let's say on the CDF you can see for this specific 550 watt module there are 3 types of glass on the CDF and 4 types of encapsulant. Now, CDF lists all the raw materials, but it also lists the material combinations that can be used. So encapsulant A can only be used with glass type C. And that has a lot to do with the tests that have been performed in the background.
Visit Sinovoltaics.com to learn more.